Today we're going to put together what we now know about mixed numbers and improper fractions, how they are just two ways to name the same fraction. So, what is a mixed number? It's called mixed because it has both whole numbers and fraction parts. So it would be a number like this, 2 3/4, because it has the whole number, 2, and it also has a fraction part, 3/4, right? Or 6 4/5. Okay, those are mixed numbers. Improper fractions, on the other hand, are numbers or fractions where the numerator is greater than the denominator. So a number like 11/4. Numerator is greater than the denominator. That's improper. That's not the way a fraction is supposed to be. Okay, or 34/5 is another example. Okay. Now, 11/4 is actually the exact same, names the exact same amount as the mixed number 2 3/4. And 34/5 also names the exact same amount as 6 4/5. Okay, today we're going to learn how we convert back and forth from mixed numbers to improper fractions, and from improper fractions back to mixed numbers. Okay, so we're going to write a mixed number and an improper fraction for each of these pictures. Okay, so this first one, how many holes do we have? We have 1, 2, 3, 4 holes, and 1 out of 4 is shaded in the last figure. Okay, so this picture shows 4 1/4 parts. Okay, another way to write this is as an improper fraction, which means I would count how many equal parts there are shaded all together. Well, remember when we're talking fractions, we need to have equal parts. These 4 have only been split into halves, so I'm going to have to subdivide them again so that I have quarters, because in this last shape here I have quarters, so I need to make sure that they're all the same. Okay, so that I can say how many quarters are shaded all together. Well, there's 4 in this first figure, there's 4 in this figure, there's 4 in this figure, there's 4 in this figure. That's 16 altogether, plus 1 more quarter, which is 17 quarters. Okay? If you look very carefully at 4 1/4, the mixed number, and 17 quarters, the improper fraction, they both name the exact same picture, but there is something in common about them, and that is that they're both quarters, okay, because our pictures have been divided into 4. But if you look really carefully, you'll probably be able to figure out how you would convert from a mixed number to an improper fraction. Yesterday, somebody discovered it purely by accident. See if you can figure that out as we go along. Okay? Okay, look at the second diagram. The second diagram, I see 3 holes and 1/2. Okay, so I have 3 1/2 circles shaded. Okay, now if I look at just the halves, I see that I have 2, 4, 6, plus 1 more half, that's 7 halves all together. So the improper fraction is 7 halves. The mixed number is 3 1/2, but they mean the exact same thing. They name the exact same picture. Okay, let's look at the last one. How many holes do I have shaded? 2. And I have no other fraction part, so my number is just, I have 2 holes. Okay, now let's name that as an improper fraction. So each of these triangles is split into how many equal parts? 1, 2, 3, 4. So we have fourths. And how many fourths do we have shaded? 1, 2, 3, 4, 5, 6, 7, 8. 8 fourths shaded. Oh, look at that. 8 divided by 4 equals 2. That must have something to do with how we would convert back and forth from improper fractions to mixed numbers. Let's see if we can draw a model for the following mixed numbers. and write the corresponding improper fraction that it's equal to. Okay? So if I were going to draw a picture for 2 3/4, I need to draw 2 holes that are colored, shaded in, and the third one would be split into quarters. And how many of those quarters would be shaded? 1, 2, 3 of those 4 quarters would be shaded. Okay? Now I'm going to write what that would look like as an improper fraction. Okay, well, how many quarters are shaded in all? Well, there'd be 4 in this first figure, 4 in this second figure, so that's 8, and then 9, 10, 11. I have 11 quarters that are shaded. Okay, that tells me that 2 3/4 is the exact same thing as 11 quarters. They name the exact same picture, don't they? Okay. Let's draw a picture for 3 1/3. So here's 1, 2, 3 that would all be shaded, and 1/3 of this one is shaded. All right, so how many thirds is that all together? If I were to write this as an improper fraction, how many thirds do I have all together? Well, in this one, I've got 1, 2, 3 thirds, 4, 5, 6 thirds, 7, 8, 9 thirds, plus one more, 10 thirds all together are shaded. That means 3 1/3 is the same thing as 10 thirds, written as an improper fraction. Okay, the last one. We have 4 2/5. So 1, 2, 3, 4 holes that are all shaded in. And the last one has been split into 5 equal parts. And 2 of those 5 are shaded in. 1, 2. Okay, well, if I have 5 equal parts here, and 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 2 more equal parts here, how many fifths is that all together? Well, how many fifths? 5, 10, 15, 20, plus 2 more, 22 fifths altogether. So 4 2/5 is the exact same thing as 22 fifths. Let's see if we can go the other way. This time we're going to draw a model for the improper fraction and write what the mixed number would be that's equivalent. Okay? Well, when I look at this fraction, I see 13/4. That means I have to have figures that I'm dividing into 4 equal groups. That's what that number on the bottom tells me. Okay, so here's some pies divided into 4 equal groups. So there'd be 4, and another 4 would be 8, 9, 10, 11, 12, and then I need 13 of them. So that means in this shape, only 1 of those would be shaded in. Whereas in these shapes, all 4, right? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 of those fourths are shaded. Now that I have my picture, it's going to be easy for me to write this as a mixed number. How many whole pies do I have? 3. And in the fourth pie, I have 1 out of the 4 parts that has been shaded. So this picture shows 3 1/4, which is the exact same thing as 13 quarters. Okay, let's try B. 7 thirds. Okay, so I need pies that are divided into thirds. Okay, so here's 1 pie divided into thirds. There's 3. Here's another pie divided into thirds. There's another 3. So that's 3, 6. My next pie divided into thirds. Okay, let's color in how I need 7 thirds. So there's 1/3, 2 thirds, 3 thirds, 4, 5, 6, 7 thirds. Okay, So let's see, what would that be as a mixed number? How many whole pies do I have shaded in? 2 whole pies and 1/3 of the third pie. 2 and 1/3 is the exact same thing as 7/3. Okay, what about 11/6? Okay, well now I need pies that are split into 6 equal parts. Okay, well I can just split it in half and split each half into 3. That makes 6. There we go. So that would be 6. And if I do that again, I'd have another 6. 6 and 6, that's 12. That's more than I need, so I can stop there. I need to shade in 11 of those 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That picture shows 11/6 shaded in. Now let's write that as a mixed number. How many whole pies are shaded in? 1. And how many of the second pie? 5 sections out of 6 altogether. So 1 and 5/6 is the exact same fraction, or names the exact same amount as 11/6. All right, so here's some pies. How many quarters would there be in 2 pies? Okay, well, how many quarters? Well, 1, 2, 3, 4, 5, 6, 7, 8. 8 quarters in 2 pies. Oh, back to what I said before. This fraction really means 8 divided by 4. That equals 2. 2 pies. Okay, let's try how many quarters there would be in 3 pies. Well, 4 plus another 4 plus another 4. That's 12 quarters. Oh, what's 12 divided by 4? 3. 3 pies. How many quarters are there in 3 and 3/4 pies? Well, how many quarters? Well, we've got 4 plus another 4, that's 8, plus another 4, that's 12, plus another 1, 2, 3, 12, 13, 14, 15 quarters. So 3 and 3/4 is the same thing as, or names the same picture as, 15 quarters. So 3 whole pies is like 3 times 4, right? Three pies that each have 4 pieces in them, right? So 3 times 4. So I'm multiplying this big number out front. I'm going to just draw it a little better. There we go. I'm multiplying this big number out front times this denominator. So I'm going this way. 4 times 3 is 12. And then I have 1, 2, 3 more pieces. So I'm adding on this 3. So I'm multiplying 4 times 3 to get 12. 3 pies that each have 4 pieces. That's 12. Plus, there are 3 more pieces in this last pie here. I'm adding that on to get this top number here, 15. 4 times 3 is 12, plus 3 more pieces is 15. That's how you convert from a mixed number to an improper fraction. Let's try a couple of these. Let's think about this for a minute. If a box holds 4 cans, how many cans will the following hold? Well, if I have 1 and 1/4 boxes, that means this one box is full. So how many cans does it have if it's full? Right, it has 4. And then I have 1/4 of a box. How many cans would that be? If it normally holds 4, and I've got 1 out of those 4. So 1 more. So I've got 4 cans, a full box, plus I've got this 1 more. I've got 5 cans in all, don't I? Look at that. That is 4 times 1 plus 1 more. 4 times 1 is 4, plus 1 more. That's 5. 5 altogether. Let's try the next one. If I have 2 full boxes, well, if each box holds 4 cans, then that means I have 8. That's 2 times 4. And then this other box has how many in it? 3. That means I have 11 cans altogether. 2 times 4 plus 3. 2 times 4, or 4 times 2, either way, plus 3 gives me 11. Okay, let's try this one. 1 full box, that means I would have 4, plus 1 more, 5. I'm not sure why they have that question on there twice. It's the exact same one we just answered a minute ago, isn't it? Oh well, we'll keep going. And this one, if I have 1 full box, I've got the 4, and then 3 more in the other box. That means I have 7 cans. Okay, that's the same thing as if we did 4 times 1, plus 3 more. 4 times 1 is 4, plus 3 more is 7. Okay, so if a box holds 6 cans this time, how many cans would we have if we had 1 and 5, 6 boxes? Okay, well, our 1 full can would have 6 cans in it, or 1 full box, I mean, would have 6 cans, plus the 5 more that are in the other box, right? 5 out of 6 in this last box. Okay, that's the same thing as if I did 6 times 1 plus 5. Right? That's going to give me 11. Okay, a box holds 8 cans this time. How many cans would we have if we have 2 full boxes? So that's 8 in each box, 2 groups of 8. That's 16. What we've done is 2 groups of 8, we've multiplied 8 times 2. And now we have 3 in the other box, so we're adding on 3. That gives us 19 altogether. 2 times 8 is 16, plus 3 is 19. A box holds 326 cans. How many cans would we have if we have 2 full boxes and 5 out of the 326 in the third box? Okay, well, if we have a box holding 326 cans and we've got 2 boxes, that's 2 groups of 326. $652. And then in the other box we have 5 more out of 3 that it will hold 326, but we've got 5 of them, so that's plus 5 more. 652 plus 5, 657, right? So what we've done is 326 times 2, and then add on plus 5 more. Tennis balls come in cans of 3. How many balls would we have if we had 7 and 1/3 cans? Well, if we have 7 groups of 3, that's 21, plus 1 more, 22 altogether in 7 and 1/3 cans. What about this one? A bottle holds 100 milliliters of water. How many milliliters of water would 7 and 53/100ths bottles hold? Well, if I have 7 bottles of 100, I'm really multiplying 7 groups of 100. That's 700. And then I also have, so plus 53 more milliliters. That's 753 milliliters altogether. Okay, so let's see if you can use that little formula to convert from each mixed number to an improper fraction. Okay, so remember it's just denominator times the whole number out front, so 2 times 2 in this case, and then add on 5 plus 1 more is 5, but that's how many halves you would have. So you still keep your denominator when you write it as an improper fraction, you still keep your denominator as halves because you're still talking about halves. You would have 5 halves, right? If you had 2 wholes, each one of those has 2 halves, so that's 4 halves altogether. Plus you'd have 1 more half, so you'd have 5 halves altogether. Okay, let's try B. So 5 times 3 is 15, plus 2 more, 17 thirds. Right. Keep your denominator, will always stay the same. What about this one? 11 times 4 is 44, plus 3 more, 47, and our denominator, we're talking still about quarters. All right, and this doesn't change even if we get into bigger numbers. It's the exact same formula. You still multiply this way and add this way. Okay, so 49 times 2, 98, plus 1 more, 99, and it's over 2, common denominator of 2. 2 times 84, plus 1 more. That's 168, plus 1, 169. Denominator will stay 2. Okay, we'll save these ones for next day. I think that's enough for today. Just learning how to convert improper or mixed numbers into improper fractions. Just remember that you multiply this way and then you add this way, and that your denominator always stays what it was in the fraction. That never changes. Okay?